Good morning, everyone.
Morning.
I'm going to talk about remote control using, or route control using Arduinos. Now, you know I've been playing with these things, so I'm going to make this, I've learned to make them work. Route control, to me, is easier than pushing several buttons, or it's easy as pushing several buttons. Usually, sometimes you get done with one. Over here, I show you this thing. It only takes about 2 buttons to make a route go from one end to the other. So, not too bad. I also needed a new test stand. The reason was this. Now, if you were out at my place last February, you probably saw that. I wanted to build something a little bit better so I could test things, code on it. The original test stand, as you can see, is a bit disorganized, and it's difficult to move sitting on that small piece of scrap plywood. If you pick it up, you're going to lose at least one servo trying to fall off and dangling. Okay, I wanted to see the Arduino and the control panels, both of them. This is the Arduino panel, this is the control panel. I wanted to see both of them at once. So, pretty much, I've met my goal. I wanted to create the push button turnout control with a panel indication on a track mimic. Now, the panel indication, I'm using red and green lights. Track mimic, just a track diagram. We should call it a mimic. I also looked at cost. Each one of these is about $11.52 per turnout. You spend more than that on buying a turnout itself. If you use a tortoise and a relays, like a few months ago in Model Railroader, if you do that, the cost is almost $32 per turnout, which is a lot more than you're paying for the turnout itself. And if you use tortoise only, it's going to run you about $25.19, and that includes the lights. And instead of a push button, a double pole, double throw toggle. All right, to do this, you got to start off with a lot of planning. You need to produce something to show the layout to begin with. And I simply took my layout, drew it out, and put the numbers on it. The red numbers are route numbers. The turnout numbers are servos and LEDs. The blue numbers. So pretty much where you see a red number, you're going to see a red push button. Once you have that, you can create this. This helps write the code. And I put the route numbers across the top, and I put the turnouts down the side. Now, you've got 2 conditions for the turnout. I call them G and R for green and red. You can call them N and R for normal and reverse if you want to, which is the usual thing, but green and red seems to stick in my head a little bit easier. I'm using green as straight through, and red being the diverging route. And all I did was, when I pushed a button, what did I want to move? And I set it up that way so that there's an X mark with each turnout. You can see some of them will get about 3 of it at the same time. I've got another board that does about 5 at once, but it takes a while to get through it. Once you have all that, you start looking at hardware. Now, the hardware, the first thing is the obvious, the microcomputers, and I'm using Arduino Megas 2560s, and you can't buy anything else now but the Rev 3. Earlier than the Rev 3, I think the 1280s are done. At any rate,
Is there a reason you picked the Mega over the standard?
more power,
Oh, yeah. More memory.
more power, there's more memory to it, and there's more pins. The standard Uno has about 21, 24 pins. This has 54 pins. So you can put a lot of stuff into it. An awful lot. Power supply, right down here. Oh, by the way, I get these either from AliExpress or I get them online where I can find the best price. I get these, I was getting them from AliExpress, I can get them just as cheap now from Amazon. This is a 12 volt, 5 amp unit. It was suggested that I get a fuse to go in there, and I did. These are just automotive fuses, 5 at 1.5 or 2 amp fuses to go in there, just to protect the whole thing. Buck converters. I've got 2 of them. The buck converter will take the voltage out of here and bring it down to what I need. This one is a 9 volt to go into the Arduinos. I'm using 9 volt because I could also take, instead of using this connection, I could use a plug-in connection from a battery, a 9 volt battery, and that'll do the same thing. It's just, you gotta keep replacing batteries. So, that's why I got that. The other one is 5 volts, and I did that to put it into this next item, which is a heck of a name, PCA 9685 PWM controller module for servos. Now,
Where back, Bobby?
Just kidding, just kidding.
PCA 9685, keep that in mind. Or the PWM controller, whatever pops in my head at the time. I got this because I had some problems originally with the Arduino not working. I had 8 connected up, 8 servos, 16 lights, about 9 push buttons, and I'd push the button and maybe a servo wouldn't throw, or a light wouldn't light, or 2 lights. So I said, maybe it's too much draw, so I started pulling things out. And sure enough, at around 6 servos, it works. Did you ever go out and try and see some of these things you buy off the market? We can teach you how to do this in about 30 seconds. Just plug it in and run it. They only take about 4 or 6 servos. Do you know why? The same problem I had. You overload it real quick. So this takes all of the load off of the Arduino and puts it back on the power supply. So this is 5 volts that goes in there. Okay, the relays for each frog, turnout frog, that requires a relay. And I say it that way because I'm building my own, I'm using fast tracks, but I've also got some Shinoharas and a couple Picos in there. They don't need to have a frog in them, or a powered frog in them. I can cut it down. This, I'm assuming that they're all, on the layout, they're all going to be fast tracks. So I've got them, one for each one of them in there, and you'll notice I've got it split up a little bit, and there's a reason that I'll explain a little later. You also need LEDs. Sometimes you don't need a pair like a crossover. I'm only using one red LED for the crossover. And to set it back to normal, there's 2 green ones. But there's LED mounts to give it a little bit more of a finished look, and then you got to buy the resistors to go in there for the LEDs. Okay, normally open push buttons, we got those. You press down on it, you send the signal back to the Arduino. They're relatively cheap. I don't like using a toggle because when I push the button and I let go, I'm stopping the signal, but it's already been sent and it's already been picked up by Arduino, so it's pretty quick. DuPont connectors. DuPont connectors are the wires, okay, that you're used to seeing with some of these. You can buy them, you can make them, and you can substitute them. Now, these I bought, and amazingly enough, the wires are either too long or just short. So I decided I don't need that much of a mess. So I decided to make it. I went out, got the crimper, got a little box, had like 900 pieces in it. And it's not only the male and the female, but it's also the connectors, or the insulators on here. And I can put them together myself. After you do 100 or so, it becomes easy.
How much is the tool?
About 15, 20 bucks.
Really? Okay.
I got mine on Amazon. It took me a while to find it, but I have been using it so much that the jaws, the that the pins have actually changed the jaws a bit. So I'm on my second one. Oh, I'm sorry, substitute them. Let's go back up real quick. Substitute them. I found out that if when I measured one of the male pins and then measured various sizes of wire, that the male pin is exactly the size of a 22 gauge wire. At that point, all I could think of was, why am I making these? And I can make it a lot neater because I can force it down. If you use solid, you can't use a stranded, you gotta use a solid wire to do that. Okay.
Yeah, and a lot of the, I've been looking at Arduinos, a lot of the basic type instructions that you read to learn about Arduinos, they have you just plug in the LED directly into the,
Oh yeah.
so you can use switch use wire.
Well, that's great if the LED was sitting right here.
Well, that as
I
a
got
test,
Yeah.
You know, to show you how it works.
Yep.
They say just plug the LED right into the socket.
Right into the Arduino, or right into a breadboard right next to the Arduino so you can see it a little bit better. But yes, you'll find that on just about every single video that's out there. Okay, servo extension wires, these. You can buy these, okay, and you don't have to try and make them. I make them. The reason is when you buy them, one, they're expensive, and two, they're either way too long for you or they're not long enough, just short. So, using the same pins, that's why I've gone through so many. I've done 97 turnouts so far, times 3. And that's the ones that I kept, so it's well over 100 just with that.
But you plug them into the plug that comes with the servo, right?
Yes, and I take,
You're talking about extensions then.
yeah, I'm talking about extension.
Gotcha.
Do this real quick. We'll look under the skirt. Okay, you can see where my wires are, that they're going through, and then
Gotcha.
they terminate at each servo. Okay? Each one of these was cut to fit, basically. A couple of them got a little long, but I'd rather have them long than short. So, I'll leave that there for a second. Terminal strips. I guess I'm not. Terminal strips. The terminal strips I get off of either eBay or AliExpress, and these are here. I bought 100. I've had to buy another box of 100, so I'll keep going. Hopefully that will get me through most things if I don't come up with too many projects to do. Arduino panel to control panel cable. To get from here to here, I had to have something. And you saw the blue cable? That blue cable is Cat 6 wire. It has 8 wires in it. All I have to do is cut it and make each one fit. I'm going to flip it around in a minute and take a look at it again.
Stranded or solid?
The what?
The Cat 6. Stranded or solid?
Oh, the Cat 6 is solid.
Solid, yeah.
You can get stranded. You can get
You
stranded.
can get stranded, but this is solid.
That was the question, just to clarify.
Yeah. All right. You're also going to need some plastic tube, and the plastic tube is to build the standoffs. And I simply get 15 or 36 inch from somebody. I just keep cutting it. You're also going to need some number 4 by 5/8 or 1/2 screws to assemble all this, because everything's got a slight standoff just to keep it cool. Now that you got all of this, how's it going to fit on the board? Make yourself a mock-up. It's that simple. Please make yourself a mock-up. This is what I ended up with after I redesigned things, different from what Doug and Dave were seeing when they built a couple of these for me. But I saw that it worked, and I was convinced that, yeah, I could do it. All I had to do was make it fit. Color code your wires, please. Get some things that are standardized. You look at the blue and the yellow wire, that's for the serial bus, the serial communications bus, the I2C. If I see black and red, especially when it's twisted, that's a 9 volt or a 5 volt. I made this 5 volts so I knew that I had something connected here that was not 9 volt. This will not take more than 6 volts if you put 7 or 8 volts in it, you surely will blow it out. Don't ask me how I know. All right, label the wires and the termination. You come up here and look, you'll see I got numbers under here. I've got everything numbered here so I know where I'm going. I've got some of these numbered. And I also, when I plug them in, this has a 0 base to it. So it goes 0, 1, 2, 3, 4, up to 15. I skip 0 unless I've got 16 connections, and then 0 becomes my 16th servo. So that way, if I'm dealing with servo number 1, it goes into pin number 1. Makes it real easy. Okay, and for heaven's sakes, keep it neat. This isn't too bad up here. It's looking fairly good. And then I've got behind all of this, it's not too bad. You'll notice that everything comes down into one area, and I'm simply peeling things off to go into the terminals. It works really well. By the time you put a couple connector brackets on there, it turns into one big wire, and it doesn't move. I originally designed this thing so that it would separate, and that's why you have the connectors in there. But I found it was tough to really separate them and then connect them back up again, so I've left it. Okay. All right, when you get one panel done, do the other one. I started with the Arduino panel and then went over here because everything's going either in or out. I needed a place to make sure that I had a good solid start. And I put all that. Okay. Code. We'll talk about the code, but fear not the code. Okay? Please do not worry about the code. And the reason is, code does not explode. There's no kaboom. All right? It just does crazy, unexplained, stupid things where it does nothing at all. Now, the good news is, before you even upload this, Arduino checks your code. So, it'll tell you if you have a problem. Some of it is very, very cryptic, and it took a while. And I knew it was going to be cryptic, but it still took a while to figure out what they were telling me. And I've gotten used to most of what they're saying. So if anybody had questions on it, get a hold of me. All right, uses a C++ reduced instruction set for everything that it does. There is an Arduino language reference that I go to just to keep reminding myself of what's there. There's the address right down there at the bottom. The documents of reference, if you go to the Arduino website, arduino.cc, at the top, you can click on documents, you'll get a drop-down list, click on references, and it'll take you right there. All right, there is a learning code or curve for the commands and when and how to use these commands. And there's some things that you can use that'll do the same thing. It's just a preference of what you want to use. A good example is a for loop, where you want to do the same thing a whole bunch of times, and using a while or do while loop, which again does a lot of repetitive work. Either one works. I've used both. For what I'm using here today, I'm using a for loop. Or not a for loop, a do loop. All right. Keep practicing and start small. Buy the Arduino starter set for about $40, $45. You can get everything and learn how to do everything from servos to photocells, to level detectors, the temperature. You can learn all of that. They'll tell you how to do it. They give you all the components to do it. I started small. I had 1 servo. I went to 2, then 4, then 8. I went back to 6, then found I could get up to more than 12. So it worked. Give your pins, your functions, and your variables English names. If I told you pin 22, what's that going to do for you? If I told you PB1, PB sort of sounds like push button. Pin 22 in here is push button 1. So that one's easy. keep it, and when we get to the code, I'll show you. All right, use comments and white space for clarity. I can't remember everything I do to the code when I put it in there and why I put it in. So I use comments. And so that I can read this stuff, I'll finish doing something, and then I'll hit the return key. And put a line, a blank line in. It separates things. You could take all the code that I'm going to show you, and you could put it right after another, and end up with something that goes all the way out, all 400 some odd lines of code that I have strung together, and it'll work. Troubleshoot, I double dare you. It doesn't work. When I show you the code, you'll see what I mean. Okay. Okay, this is for the master. Now, I've got two Arduinos here. One is the master, the other is the slave. This one tells this one what to do, and it does it through the I2C network. All right, you can see I've got a lot of comments is where I start. The first line, I got a slash and a star, and that starts a block. In other cases, you'll see just a couple of slashes, like here, and that's one line. But the block has the star, slash star, and then star slash. So this is what I put in there, just a reminder of what the heck I was doing and where I started and why I'm doing some of this stuff. All right, let's go back to here. General layout, the declaration section for the code. All right, there's two positive sections you gotta have. This precedes all that. And this is, I simply call it declaration because I'm trying to declare all my variables up in here. Like this one, I'm including the wire and the PWM servo driver headers. Another set of commands, and it just goes out and finds them. You can use it. It saves you a lot of time trying to develop another set of commands. So everything seems to work really well. That was sort of a godsend with this thing, which is still a bit of an enigma. Okay, here I'm calling it PWM1. So I've defined it, and every time I want this to do something, I put in PWM1 and then tell it what to do. Okay, I've got some variables defined in there. One is a sweep delay, and I use that for the servos. And then I've got some tables down here. This is one of the things that was new that I wanted to see if it would work. I have a table for all the high limits for the servo, another table for all the low limits for the servo, and then another table for where's the servo now? What's the last position? I put those all in there, and it seems to be working really well. All right, next, pin 22 is PB1. So if it's a PB, it's a push button. If it says LED, which are all on the slave, it's a light. And the light will be associated with the turnout, and it'll either be red or green. And we'll see that in a few minutes. The relays, again, I call it a relay. There's no real surprises with that. All right, the next thing is setup function. You gotta have a setup function in Arduino. In fact, when you open up Arduino and put in a blank sketch, there's two things that are in there. One is the setup function, and the other is the loop function.
Tell us what a sketch is.
A what?
Tell us what a sketch is.
Okay, a sketch. It's the program. Okay? The application itself. So, they simply call it a sketch. I don't know, it was created by Arduino. It's a bunch of Italian guys that got together and do this.
Instead of calling it a program.
So, well, they did it a program. Okay. Anyhow, this runs once. And it's things that you only need to run once, such as initializing things. I gotta start up the network. That's what I'm doing first. Next, after that, I'm down to the PWM1, and I'm telling it to begin. I set the frequency. From what I was reading, this number was about right. They're saying 50 or 60 as the frequency that you use in there. And then I put a delay 10 in there to stop take a breath, and make sure everything's running. Next, you gotta define the input-output mode, and everything that you have for an input-output has to show up here, which means that you have to define it before you get here, which is the declaration section. Okay. I also put my physical limits in. This all starts at 0. Those are my base numbers. So after that, when I start setting this up and checking the functions, I can put in what I want. The next thing I do is I got to initialize the turnout. And I'm using this as something new, and it seemed to work really great. It eliminates a problem I'll talk about in a little bit. But what I'm doing is I'm taking the high and the low limit, I'm averaging it and putting that in. So when this thing starts up, you're going to see everything move slightly. Okay. The loop is a continuous loop. This is where you're checking to see what you're going to do. So if I push a button, the loop's doing this, and it says, oh, I got a button, wait, this is this one, right here. And that's going to start doing the code for that button every single time. You change buttons, it'll do whatever else you've got in there. But you're constantly looking, monitoring what's going on, because it never knows when you're going to punch a button. And what you're putting in there, just a little bit of an if statement that says if the digital read for push button 1 is equal to low. Now, it's a double equal sign because it's a comparison. If you put a single equal in there, it's going to try and replace it, and you'll get an error. So, just watch the syntax if you're not sure. Take a look on the Arduino site. And you can see every single one of them, I'm doing something with it. TV3 changes an awful lot. 2, 3, 6, 7, and 8. Also, when I get done, I'm using a function that I built called send root. And the number that I'm putting in there is the root number that I want it to take. And you can see push button 2, root 2, it got easy. And I can also check myself and see whether I've got problems real fast.
And you got this off of that list that you made initially?
Yes, I did. Well, this, the send root and the turnouts, I build in the final section. And I'll show you that in a second here. But this is all going through, just checking to see what's there. And the next thing I'm building is the function section. Now, I tend to put them all in one place. You can scatter them out if you want. You can put them almost anywhere in the programming you want. But I tend to put them in one place so that I can go down and I can find it every single time, and I know where it is. A lot of times it's just easier just to drag all the code to the bottom and then come back up. But the function is on demand. And by on demand, it's a call. And right here, I can see push button 13, what it takes, and it's a turnout. And if I go to 8 and 9, there's 8. The first thing I do is I set a pointer to number 8. Then I tell it I want to see the last position replaced by the function, which is turnout throw. And I'm using the I for my turnouts. And I can go to the tables and I can pick it out every single time. And it works a little bit faster than other ways. The next thing is the relay, and finally a sweep delay, which is only 6 milliseconds. And then if I am using the serial monitor, I can see what the turnout has done. It'll tell me which turnout it is, it'll show me the last position, and it'll show me where it's supposed to be. And if it doesn't get there, I can see where I have a problem. Okay, here. All right, the basic process flow. Push button selects a root. The root calls the turnout functions, okay? Come down, run whatever functions I need, It also sets LEDs if there are any on here. If I have a smaller number of servos, I'll put the LEDs on just one. Then finally, the turnout functions. We'll throw the servo and set a relay. Okay. The I2C network. It's simply serial communications. You have to include the wire H header. I showed you that earlier. The setup function is you start it with wire begin. If you leave the parentheses blank, you end up with that being the master. It's sending. If you put a number in there, and you'll see that when we get to the slave, you put a number in there, you're going to end up calling, giving that an address for this to send it. So when I do send anything, I can send it to where I want it to go, like PWM, or in the case of another Arduino, an address for it. You have to set the baud rate. The baud rate has to be equal every single time. And that's for everything on the network. Okay, before I get into that, let's go here again. And here's the data. Okay, there's send route right here. So wire begin transmission 4. That's what I've called the second Arduino. I'll give it an address of 4. Then I write it, and I'm writing the route number, and then end transmission. So I stop transmitting. I'll put a little delay in it, just to make sure everything settles out. And I've got the information transmitted over here. We'll look at them in a few minutes.
Sandy, what's the highest baud rate that's reliable you can use?
Depends on the,
115,000?
yeah, on the IC2.
Yeah.
Yeah. But you should use that shielded, distance has a lot to do with it.
Yeah. That's what I said, reliable.
Well,
Yeah. Now,
What's
what I
the
have
baud
up
rate?
here, between here and between here and here,
Yeah.
you'll go online, you'll see everybody wants you to use a resistor in there. They'll give you the drawing for the circuit. What I found out later, and proved it when I tested it, is I don't need that 10K ohm resistor if my distance here is less than 3 feet.
that's kind of what I was talking about.
So,
But you can go 250, 300 feet if you want to.
oh yeah,
Without a problem, but you gotta use that thin, triax. It's got 2 wires inside of it, it's got a shield.
Yeah.
Real skinny,
Are they twisted?
Yeah.
Yeah, okay.
okay.
but the shield's a big thing.
PWM servo driver, you gotta have the header file in the declarations, which I showed you earlier. You define the global variables, which I showed you earlier, and then you define the servo tables. That was all done earlier, and everything was input. The tables are 0-based, but I start my data with 1 because I'm dealing with turnouts that are numbered that way. In the setup, you simply define the high and low limits and the last position for each servo. And you need all of those to make this work and get rid of a problem. Okay, the slave. Here's the slave.
Guess you could define the zero turnout.
Yeah. If I call it 0, but for some reason my head doesn't wrap around it. Okay. The slave controls the LEDs. It controls relays if necessary, and in this case I purposely put them that way. It uses the same wire H header file, and when you define, or you have to define a variable called root number, or something that you understand is the root number coming from the master to the slave. This simply stores the number that's coming from the master. Okay. We'll work that.
Of course, you're gonna use that number as entry into the lookup table.
Oh yeah. Well, not the lookup, but I'm actually using it in the loop,
Okay.
okay? There's the wire. There's my LED pins. And I even put comments in there for the ones that I'm not using. The reason is I don't have to wire them. And I know which ones I'm not gonna wire. Otherwise I forget. There's my output again, and there's the serial. Notice the wire begin 4. I still got the baud rate, and I simply start off by saying, if I'm using the serial monitor, this is the one that I'm looking at. This is the Arduino I'm looking at. And then wire 1 receive. This is important, because without this, you're not going to get anything from the master. The receive event is the name of a function that you write what happens when you get data from the master. Okay. You need that to get communication from the other devices. You have to include a data type and a name for the data passed in parentheses. Now, it sounds stupid, I've never really used that number because everything's so close and I'm only sending bytes or integers to begin with, actually bytes. But receive event is the name of the function, and the variable that goes in there is an integer. And after about 4 or 5 people using how many, I decided, well, let's use how many and see what happens. Because I was having a little problem with it. Okay, the receive event receives and stores a root number from a master. The loop compares the root number to the options and sets the LEDs and relays. And then the root number is set to 0. So the number I had, when I'm done setting everything, I set it to 0 so it doesn't keep running through and resetting relays and lights. Turn things on, you turn things off. If you don't, you have problems. We'll come back to that in a minute. Okay. I've got a couple others in here. You'll see things like the lights on here. When I turn it on, the lights will come on. They'll stay on for about 5 seconds so I can take a quick scan at it. And then they all turn off. And it's okay because when I need it again, I go up and push a button and the proper lights light up. It'll show the routes that I have available to go through there. You can see every single one of them tells me what I need to do. Now, okay, a couple of these, I can turn a pair of lights on and off. Well, if I've got anything besides a crossover, I can do that. Or I can turn one light on, turn the other light off for that turn. Where? Okay, there's the receive event. I'm simply going to take the root number and I replace it with wire read. And that gets my information into this Arduino. That's how they're built. But like anything, I find out there's problems. There's always a problem. One of them is fairly well known, and the other one I discovered last February when everybody came over. Which is why things didn't go that well. So, you discover them through experience. Both the problems to me are annoying, and I had to do something with them, but I solved them through research and testing. All right, the first problem is called servo bounce. And you start reading about this, and there's people that will tell you there's a problem with servo bounce. It'll jump. Well, what happens is it's sitting there, and all of a sudden you press a button to get the servo to do something. It'll jump like this and then come back slowly, or it'll jump. It'll slam against the other direction. This is not good for the turnouts. So, I did some more research. It occurs when repositioning the servo, but the servo is already in the desired position. If you want it to go to the high limit, it's already there, You punch the button, it's gonna drive over to low and then come back slowly. That's what was driving me nuts. How do you stop it? Well, the answer is do it with code. But I found out it was also a problem. This is a servo problem, because the same thing will happen whether you use this or, like Andy's going to show you next time, on how you're being servoed.
Are you being served?
Yes. It occurs with both sets of header files. So that means it's all in that little blue container. All right. How do you fix this thing? Well, there's two ways. First, use the turnout throw function. It avoids positioning if in the last position, and it stores the last position of the servo. Now, what do I mean? Down. There. This is the turnout throw. Where I wrote the code, and I'll move up and show you again. The turnout throw expects three things. It expects an integer that I'm calling servo number. It expects an integer that I'm saying is servo 2, where I want to go. And it expects another integer that is the last position, the servo last. And when I go back up and look at it, there it is right there. I'm going to say the last position is equal to the turnout throw. There's my servo number. There's a high limit, and there's where my last position was. If you do that, there are two things that occur. Now I put in the servo last to pause, because everything I was doing was pause, and somehow pause is now ingrained in my head, and I made a couple stupid mistakes by not using pause, so I went back to using pause. Besides, I don't change servo last, and I change pause, and that's going to change every single time. Okay, I ask it, is where you're going less than where you are? If it is, I'm going to run this code. And the code is going to reposition the servo. And there's the command to PW1 to do it. Put a delay in it. And the delay is only 6 milliseconds. So as it does this, as fast as the code's moving, your turnout throw is slow. So that's why all that's in there. The next thing is the pause says increment pause by 1. And then do it again. Every time you go through the loop until you get to the pause. Now, it also asks the question, if that isn't right, it'll ask the question if the servo 2 is less than pause. Again, I can determine whether I'm already there or not. If I'm already there, if I'm not less than, it's going to run that. So essentially, it doesn't run until I find out that it's got someplace to go. If it's in the position I want already, it will do nothing. And the bounce does not happen. Okay, and this other code down here, the difference from the first code is it's a minus pause. In other words, de-increment. So one way I'm moving it up, moving it back. Now when I get done, I have a return pause in there, and the return pause is simply telling me that's what I'm going to return. In this case, where I am right now. And when I return it, it's going to go into the storage spot for this pause. The last place. And I'll do that every single time. That's what keeps this thing, keeps it working. Okay? The other is to initialize to 90 degrees. Well, I didn't initialize to 90 degrees because I had too big a spread using this. So I tried something else. I took the high and the low and averaged it and said set it to that the first time around. And I did that in my setup. So each one of them, and when we start this up, you'll see the arms, one at a time, go ahead and position themselves to halfway in between.
So the switch is open.
Yes, the switch is open. But what happens when you want to run through? You don't have any lights, go up and punch a button. Guess what that does? It says set all of these that you want to go through.
And all the others are still open.
and the others are still open. They don't move at all.
Okay, now we're done with one route and we've selected another route.
Yes.
Now, the previous route, if those switches are not going to be used, are going to be in a position.
Yes, they're gonna be in a position.
They don't go back to neutral.
They don't go back to neutral. Everything, once you get it past the neutral,
Right.
this thing is exactly where you need it to be to press a button and it'll change. If it doesn't change the code.
So the only time it does that is on initialization,
Yes, that's the only time it does it.
up until the first use.
Yes, up until the first use. Okay?
That's okay.
All right. Problem number 2, those blinking relays. And this is what occurred last February. And I got up there, we started running things, and the next thing you know, we couldn't get anything to work. Because the relays were blinking on and off, and on and off, and on and off. And I thought, okay, I'll try this fix. So I did that, and I happened to be underneath, and each one of my panels has got a separate switch to power the 120 coming into the power supply. And I flipped it on, I thought, okay, let's wait and see. Within 30 seconds, it was on and off, and on and off. It was driving me nuts, and I was upset and frustrated, and I reached up, and I grabbed this loop, and I pulled. The ones that were still connected, because I was dealing with 15 relays. The ones that were still connected stopped. And I thought, can I find a threshold? So I took one wire at a time, putting it back in. 9 was in, so I put in 10, 11, 12, gave it a chance to shoot itself in the foot, which it didn't. But when I put 13 up and I touched the contact, it sparked. And I thought, is that it? Forced it all the way in, and they came on, and they went off. And they came on, and they went off. So I pulled the 13th one out, and everything stopped. So I thought, okay, I guess my limit, my threshold, is 12. I can get that far. What was happening is I was getting overloading. I had way too much on the Arduino. So,
Too much what, drawing current through it?
evidently it was. Because the things that I did to it after that, attach fewer relays up here and distribute the load, which I did down to there. And I did that and came up with a self-imposed limit of 8, conveniently for this, and a maximum of 10. That way I don't get to 12. So I can still get everything to work. I'm sorry?
You got a little buffer there.
I have a little buffer there. If I absolutely have to go to 12, I'll feel confident going to 12. But if not, and I get those blinking lights again, then I know what to do.
Okay.
Now,
I got a question for you.
go ahead.
Those are what voltage relays? What's the
These
voltage?
are running off the 5 volts
5 volts.
for the Arduino.
What's their current rating on each?
These, the outputs,
No, the draw.
The draw,
oh,
the
I
coil,
don't know, like 10,
10 milliamps?
no, 20 milliamps is supposed to be what it is, but I'm finding that may not be true. Also,
So the
the fact
Arduino has a limit as to how much it can, it's drawing from the power supply.
Yeah.
And it has a limit as to what it can handle. Is that anywhere in the specs on the Arduino?
I keep trying to find it, and I found it one time, I went back to confirm it another time because I'd forgotten it. And I was thinking, there's 1 amp that was in here. And of course, with 20 milliamps, you start connecting things up, it'll go real quick. It's only like about a half an amp in the Unos. But this, I was fighting this so long and so hard that I just decided to make sure everything was less.
Yeah.
When you put 15 or 16 on here, And you
What we
connect it
did
to
on that
one.
first board we were building, right?
Yes. One of the first, well, the 304 board.
Yeah.
Anyhow, that has 15 relays in it, 16 turnouts, about 30 lights, and you put that all in there, and it's a joke. So that's when I started splitting things out, and that's how I got this.
Can you have multiple slaves?
Yes, you can have multiple slaves.
Oh, yeah.
I,
Each one's got a different address.
Perfect, okay, yeah.
now, I have one panel that is 20 turnouts, which means, and there's two Shinoharas in there, a double slip switch. So that means I have 18 turnouts, plus there's like 38 lights, and 18 relays. To make all of this work, I'm gonna have to have at least 2 8s plus a 2. And I may need to go to a third relay, but that's okay. Because the third relay, or the third Arduino, not relay, but the third Arduino to take care of the relays is fine. And I can group them however I need them at that point.
Now, 30 could be an Uno then too, because it's your only using
Yeah,
part.
it could be.
Yeah.
Yeah, it doesn't matter, because all it knows is this something that I can use when it gets it off the I2C? And if it's not, then it doesn't care. So that took care of my 2 major problems. All right, handouts. It's all on here. The presentation, the masters and a slave for the demo panel here. And then I threw in the actual what I created initially for this panel, which is based on Union Bridge West, the west end, for a master and a slave. And so you can compare it. I threw in New Windsor, which uses the servo H header. And it's got a few other different things in there. So you can see what's going on with it.
Good.
Yep.
And well remarked, I take it.
Norton. Oh, no.
Answer you again later.
Waste of money.
Yes. I know, I did that. Okay. Are there any questions before I fire this up? I'm gonna plug this thing in.
Is it gonna smoke?
It didn't earlier. We got it this time. All right, you saw the lights go on, the lights go off, these go on, and they'll go off. Won't you? There we go. Finally, there's a different 5-second delay in one of them. Now,
It's because it's got to go through the serial bus.
yeah,
That's a tech test for all the lights too, right? You do that for
yes,
a panel test?
it's a panel test
Yeah.
to make sure that the lights are working. I also do the lights down here, but I can hear it as well, so I don't have to crawl underneath the layout. And if I don't hear it, I go down and see what's going on. Or if I hear click, 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 then I know I got a problem. Well, have I got that set up? No, hang on. Shut you down real quick. And we'll go back. And I'm on column 3. Okay. So now it's communicating. And tools and serial monitor. It comes in and it says I'm on the demo panel for the master. So that just lets me know where things are. I've gone through the whole startup. And if you paid attention, you saw everything move. So if I can get over here without killing myself or destroying something.
I can't see it.
Yeah, if you don't want to look, okay.
Okay.
You can start off, and this is turnout number 1. I'm going to hit
Orange.
the button, and you'll notice it jumped a little bit. If I hit the button over here, you'll notice it moves. Okay? If I do that, but I need to get a train in here, well, there's all sorts of things I can do. Which route do I want? The route, I can come through here, I can come to here, And I've got lights that go all the way down through here, and I can go all the way through town on the main line. To get to the yard, all I have to do is that, and then select where I want to go in the yard. If I'm trying to do a runaround maneuver, I can come in, go around, come back, and go straight in. These don't come on unless I press them. This is actually a fuel facility up here. The lower line is for coal, the upper two are for diesel fuel for some RDC units that are commuters. But everything seems to work. Excuse me, I'm not getting any bounce. And if you watch the relays over here, you'll see that they end up doing exactly what they're supposed to do. The lights go on, the lights go off. Make sure that you do testing when you're done.
Doug,
Find a way.
yes, absolutely.
Oh, sorry about that.
The camera.
It's okay, I just want to see that.
Well, if you want to press it, go ahead. Pick one.
Pick one. Now watch the little yellow arm.
Mit der Lights wicken und blicken und der Arm geschwingen.
It's pretty fast.
Well, you can slow it down by
I
going to
like
the delay sweep and changing it from 6 milliseconds to 10 milliseconds. When I first started, they were recommending 20. No. That's too long. But, yes, it moves fast, but it's also slow.
I like that speed personally.
That's why I selected it.
Because I liked it?
Yes, because I like it too. But yes, everything will work here. 2 Arduinos, the PWM module, 10 relays. It works every single time. And keeping this in mind, I did not spend $25 with a tortoise plus $25 for a turnout. That's $50 a turnout, which means this panel would cost somewhere around $500 with everything in it.
That panel as it stands right now is less than $100.
A little bit more. It was about $11.50 for one of these. It cost me about $11 to $12 to make the turnout. So I'm looking at $22 to $24 times 10. I'm $240 for the entire panel. And it works the way I want it to work.
With the switches.
With the switch, yeah, everything you see in here. I went down, originally this was running me about $8 a turnout. And then the prices have since gone up. I went back about 2 months ago and I repriced everything, because I got a spreadsheet that does that for me. Repriced everything and came up with the numbers that I gave you that were in here. Okay, as you can see, when I threw something, I got plenty of numbers in there. And the important thing is that number and that number have to match. Yahoo, huh?
Very cool.
It is. And that's why I like this route control thing. Now think about this. This is a little food for thought for everybody. If I can do this with these lights, what can I do with a multicolored signal mast?
Right.
And how do I flip it? And the answer I've come up with is, I can buy about $1.25, $1.50 IR transmitter and receiver module. That as soon as you get the bounce off of the IR back in the receiver, it now gives me an indication. Now, if I use that as a push button, then I can control the lights that go in and out. And I've always had a problem with how am I going to get something from my upper level through the mountain and into the staging? Well, I already bought the signal bridge and I bought some signals to go on it. And I've developed a method that I can come up there, and all you have to do is you push a button, and a light on the other side, over on the staging side, will start flashing. And the operator, the yard master over there, can see where he's got a train, hit a couple of buttons, and get the train in. The real problem is getting the train out, because they can't see each other, they can't talk to each other. I created my own aspect by adding a searchlight at the top. And when the searchlight is on and white, it means that the yard master and staging has cleared you to come out. You've already got your cards, you've already tested to see that your engine is connected to your throttle, your phone, and you can then pull it out and it'll go either on the main or into the yard.
Say too, as a person who's partially red-green colorblind, your choice of green LEDs there is great because there's great contrast for me between them.
That has to
Those LEDs that have the combined red-green, the older style ones,
Yes.
I could never tell those apart.
There are the tricolors that work off, in fact, you can set them with the PWM. You can set them to whatever color you want.
On mine, I use red and blue just because there's no doubt in my mind what color it is.
There you go. If you got a green problem with your color blindness, then yeah, pick another color for heaven's sakes. But I also found that
Well, it's an intensity and size function with me. I can't
Yes.
pass the book, but in order to fly at night, I had to go take a test down at the Birmingham Gato where they shut the lights at me and I could easily see them.
the greens have got 330 ohm resistors in them. Now it sounds a little low, but can you see them?
Oh,
Oh,
yeah.
yeah.
That was the point. When you build a control panel, if you can't read what's there,
Yeah.
you've done something wrong.
There's no problem for me at all with that panel right there.
Yep.
And I've seen some that I look at and they're just all the same color.
Yes, sir.
When we were at your place, you also had a little bit of problem with Wi-Fi.
I did.
Has that been cured?
Oh, yes.
Okay.
In fact, I've installed a second Wi-Fi, and when I put a password on, I can go from 4 positions to 8 positions on each one of them, which means that I could have 16 people logged in and running, plus I've got 5 radio throttles for NCE that you can use to make things move. And one of them is going in the Baltimore area because it's got a yard plus the passenger terminal, and the other one is going into Cumberland because it's the biggest yard and there's going to be a lot of things coming in and out.
You can also use your phone-based Wi-Fi?
Yes,
Okay.
that's what I was talking. That Wi-Fi, when you install it without putting a password in, there's 4 slots. When you put the password in, it goes to 8. Yes. Now, it costs. I bought 2 of them because the 2 of them cost less than a single NCE throttle. Yeah. Or,
So my engine driver on my phone works with yours.
yes.
Okay.
Yes, it does. It is an Android base, but if you have an iPhone, just get the right one. I can tell you which one it is. I do not throw away documentation. Okay, I have a binder for the Wi-Fi alone. Not big binder, but it's a binder.
Okay.
Okay, any other questions?